So in the build up to Biofabrication 2021, the annual meeting of the International Society for Biofabrication held online in September, we're chatting to Professor Svetha Venkatesh from Deakin University, who will be a plenary speaker for the conference. Thanks for joining me, Svetha.
Thank you.
Look, we're very excited to have you as one of our plenary speakers for Biofab. So I just wanted to have a really quick conversation with you about the conference and what we can expect from you as a plenary speaker. So, first and foremost, how does your work, I guess, and you can tell us a little bit about what you do, sort of relate to Biofab?
So I'm a computer scientist, and my area of research is machine learning and AI. And about 7 or 8 years ago, we started to look at what we can do with machine learning and small amounts of data as opposed to large amounts of data. And in the space of experimental design, this intersects very well. So if you're doing an experiment and you have a bunch of variables and you're trying to achieve an optimal outcome, then what's the best, how can machine learning help so that you can do the minimum number of experiments? So I think that's where we intersect with biofabrication. So in biofabrication, there are many problems where you need to do some experiments in order to figure out the composition of an ink, composition of settings or whatever. And I guess our work intersects in coming in and trying to use machine learning to make that process more efficient.
Right. So I imagine throughout your career, you've had to come across and, I guess, collaborate with many people in the biofabrication space. I mean, Professor Gordon Wallace here, you've obviously, worked with him in the past, I'm sure. How do you go when you're, I guess, working alongside these biofabricators?
So machine learning is a weird thing. We kind of treat the biofabrication as a black box. So we don't know anything about what's happening there. We kind of assume that you tell us what the input is and what the output is. And our job is to model that relationship through some kind of mathematical function. So however, in working with our colleagues, the more knowledge they give us about the system, we can make the modeling much more efficient. So it's quite a seamless process, and our kind of methods transfer across domains as well to other experiments, for example, in alloy design or materials design equally. Right.
And as I mentioned at the start of this chat, you'll be a plenary speaker at the conference coming up. So I'm just wondering, what's the gist of the latest news you'll be sharing?
Right. So I will be focusing on how machine learning can be used for these kind of tasks, for accelerating experimental design more broadly. And I will share the kind of experiments we have done and the results that we have achieved using these processes.
Great. Well, yeah, I'm looking forward to it. And I'm sure everyone else that's going to watch this is looking forward to it as well. I'm wondering as well if we can look into the future a little bit, and I wanted to ask you where you might think the field of biofabrication might be in, say, 5 years' time.
So Gordon and I were talking about this a little bit, and we hope that, along with AI, we can make this automated AI assistant who can help in this kind of process. So, you go into the lab and then you have this intelligent agent that can help you navigate these kind of complex spaces. We're quite far away from that goal, but perhaps that's what we are aiming for.
Yeah, exciting times for yourself and all the other biofabricators around the world. Look, well, yeah, thanks so much for your time, Svetha. It was really nice to have a quick catch up and build up a bit of anticipation for the conference and for your presentation as a plenary speaker. So yeah, thanks so much.
Yeah, no worries. Thank you so much.